Find the missing value in the table below. We have a bunch of x's here, and we have a bunch of y values. Now first, let's look for a pattern. We're adding one here, we're adding one here, here, but unfortunately we're adding 3 here, so the pattern is broken. If we were to focus on the pattern, we can see that we're increasing by 0.2. We're adding 0.2, and we're adding 0.2, and we're adding 0.2. But because we're adding 0.2 when we increase the x value by 1, when we increase by 3, we're simply going to add 3 times 0.2. So 3 times 0.2 is 0.6. So by going up by 3 units for the x value, we're going to go up by 0.6 units for the y value. 3.2 plus 0.6 is 3.8. So this is pretty quick. If you don't see the pattern, you can always focus on the points. 0, 3 and 1, 3.2 are 2 examples of points you can use. So I'll write it here, 0, 3 and 1, 3.2. So we can always try to find a line equation. It begins by finding the slope. The slope is rise over run. This minus this, we're subtracting the y values, is 3.2 minus 3, which happens to be 0.2. Whereas the run is 1 minus 0. 1 minus 0 happens to be 1, so the slope is 0.2. Recall the slope point form. Y minus y1 is equals to mx minus x1. We can use either point. Let's just use this nice point here, 0, 3. So y minus 3 is equals to the slope, which we figured out was 0.2, x minus x1, which happens to be 0. So this is the valid line equation. And we simply have to figure out the y value when x is 4. So we have y minus 3 equals 0.2, 4 minus 0, which happens to be just 4. 0.2 times 4 is 0.8. And when we throw the negative 3 over, it becomes positive 3. So 3 plus 0.8 is 3.8. So as you can see, we have the correct answer, and we can do it either way.